Okay, continuing on with solving linear equations in different forms. We've got ax plus b equals cx plus d. Notice we've got a variable on either side. That just means, as you can probably kind of guess, is we're just going to still kind of get variables together. So let's just see what our objective is. Obviously determine whether an equation is conditional equation, an identity, or a contradiction. Okay, let's just kind of remember what those are. They'll give us some examples here very shortly. Here's the procedure, which I'll leave up. Obviously, it's going to be in your PDF, but this is going to be one of those that we'll just kind of go through with examples. Okay. So here, let's just kind of see what they're saying here. This is one of the form of ax plus b. Notice that b is a constant. The d is also going to be a constant. This has got a coefficient. The c is going to be a coefficient. Okay. Got 5x plus 3 equals 2x minus 18. Well, what I'm going to do first is I'm going to worry about the variables first. What they're worried about is the constants first. So get the constant over to one side. And notice once you get this minus 3 over to this side, you've got the 5x equals 2x minus 21. Okay, well then what they're going to do is get this 2x, and since we got subtraction happening here, we got a positive, we're going to subtract 2x from both sides. And what that's going to do is give us just 3x here, and then divide off the 3, and you got the x equals 7. And then what they're going to do is come back in and check it out. Just like we've done. Plug it all back in. Does it equal? Yes. Okay, let's continue on here. Okay, let's try this one out for ourselves. So notice we've got 4x plus 1 minus x equals 2x minus 13 plus 5. First things first, combine like terms first. Okay, so let's just go and combine as we go along. I've got 4 minus 1. Remember, there's a 1 in front of there. So 4 minus 1 is going to be 3x, and I'm going to have this plus 1 here. All equal to what? Okay, well, I've got 2x minus 13 plus 5. Well, notice the 2x is fine. Okay, so then we've got this negative 13 plus 5. So that's going to give us an 8, a negative 8. Okay. All right, so now we've got this in this form here. So let's go ahead and start getting everything over. Notice I'm going to go ahead and take the 1 and I'm going to subtract it off both sides here. And that's going to leave me with 3x equals 2x. Well, negative 8 minus 1 is going to give me a minus 9. Okay, well, notice I still have this x sitting over here, so I need to go ahead and just divide this 2 off. Okay, so divide the 2. Sorry, not divide the 2. I am subtracting 2x from this side, and then I'm going to subtract 2x from this side, not dividing, because we still have an operation of plus or minus happening over here. So, continuing on, 3x minus 2x is just going to leave me with x. This reduces out, and it's going to leave me with negative 9, which we can go back in and check. I'll do it in blue over here. We've got 4 times negative 9 plus 1 minus a negative 9, okay, is equal to 2 times negative 9, put that in there just very sneakily, minus 13 plus 5. Okay, so 4 times negative 9 is going to give me a negative 36. Okay, then I've got plus 1, and then notice I've got a negative and a negative. That's going to give me a positive. That's going to give me 9. Then 2 times negative 9 is going to give me negative 18 minus 13 plus 5. Negative 36 plus 1 is going to give me negative, negative 36 plus 1 is going to give me negative 35. Okay, plus another 1 is going to give me negative 26. Let's double check that. Negative 35 plus 9. Yep, negative 26, just like I thought. Then we've got negative 18 and a negative 13. That's going to give me a negative 31. Everything going good here? Sorry. Yes, negative 31. But then plus 5 is going to give me the negative 26 on this side. And so, therefore, everything equals out. Everything is all right in the world. Okay, let's continue on with some other examples here. Okay. Solving linear equations involving fractions. Well, just like I've done with every other fraction, guess what? I'm going to get rid of the fractions first, because why deal with them? Okay, first off, we don't like them in that form. Okay, you really, as we get further and further along, we don't want things in fractional form if we can prevent it. Notice I have an LCD of 15. Okay, so let's multiply everything by 15. And I do mean everything. Look, you got to come in here. Even that -1, you got to multiply it by 15. Okay? So here I've got 3. That's going to reduce this 15 down to a 5. 15s are just going to be gone. The 5 goes to a 1. This one goes to a 3. And then here nothing reduces out. So then, let me get another pen out here. We're going to have 5 times 1, which is going to give us 5x. Well, here that just reduced out. We can keep the plus symbol and just keep that 13. All equal to, well, what do we got here? This reduced out to a 3, so 3 times 3 is going to be a 9x. And then we're going to have this -15 here, minus 15. Now we've got this in it's a lot nicer of a term now. Now, one thing I want you to be aware of is notice I've got a 9 here and a 5 here. Well, if I move this 13 over to here, I'm going to end up having to move that 9 over here, which is going to give me a negative, which is just fine. It's okay. You're just going to end up having to divide off the negative. But I like to see if I can make things a lot easier for myself. So what I'm going to do is I'm going to go ahead and come in here and add 15 to this side. That reduces out there, and then I can rewrite. I'm going to have 5x, okay, plus 28, all equal to 9x. Okay, well now look what I can do. I can take this 5x, subtract it off from both sides. This reduces out. Now I got 9 minus 5, which is going to give me 4. Okay, so that's going to give me the 4x is equal to 28. Divide off the 4 because we want to get that alone. Okay, and then notice 28 divided by 4 is going to give us 7. So let me get the pen out here. You get x equals 7. And of course you can plug that back in. Whenever you do, you're going to plug that back in as 7 over 1 because that's going to help out a little bit whenever in your multiplication process there. But going from there, and then just continue on. Let's do one more here. Actually, let's jump to this one right here. Okay. The reason I'm keeping this one as the way it is I want you to see what conditional and stuff like that is. Okay, so we've got determine whether the equation 3 times x minus x plus 5 plus 1 is equal to -11 is conditional equation, an identity, or a contradiction. Okay, notice here what they do is they distribute this guy out. In fact, I'll draw the lines here. Here they come in and they distribute. This is how they get to this part here. Okay, notice they're going to combine like terms here. This is where they get to 16. Subtract 16 from both sides. You get 3x equals -27. So 3x, and then they're going to divide off to 3, and then you get x is equal to -9. Well, what kind of problem is this? Because they're asking you, is it conditional, an identity, or a contradiction? Okay, the equation has one solution, therefore it is conditional. Okay, one solution is conditional. Okay, so if you have something like, say, an identity, okay, an identity would be something of the form, hold on. Okay, I paused the video real quick, just kind of pull this up. That way you have more of something to look at here. This is not going to be something that's going to be in your, it's probably going to be in your book and maybe even in your PowerPoint slide, maybe if we went down a little bit further. But notice that we just came up with a conditional, okay, which was going to be this guy right here. Okay, notice because it has x equals, which is what we found from our last statement, because we saw that x equaled -9. Well, a contradiction will be something like this. Notice how they're saying like something where -3 equals -7. Well, that doesn't make any sense. Okay, so that would be a contradiction where you get different numbers on either side. And then an identity, okay, is whenever you have something like it says here, 0 equals 0, but you could have 1 equals 1. We saw 7 equals 7, and just etc. That means all real numbers. No matter what number we put in there, it's always going to work, which is what that means. So whenever you're solving these, if you come up with one that you get like this, -3 equals 7, well, that's why. You're going to have a contradiction. That doesn't work, okay? Conditional means you just have one answer, x equals, y equals, b equals, whatever, okay? And so that's kind of how that works. So let's continue on. We'll do some Hawk examples.